So in this video we're going to refactor the @test algorithm code into a set of library methods that have unit tests surrounding them, and all will be excellent. So I'm going to start by creating a new @test method, and in that @test method I'm going to write what I think this code should look like. So I'll just start by calling this binary chop 1024.22048, and we'll gradually build this up. Now I think that what I'm going to have is I'm going to have a binary chopifier. I don't think I'll add anything in that constructor, and what I'll say is binary chopper.chop. I'll put the values in there, so 1024 to 2048. I think this will return some results. So rather than put the reporting into the chop method, I'll return some binary chop results, which I can then put into a reporter, and we can report on that way. So I'll probably have something like new binary chop reporter for the binary chop dot, I don't know, get string report, and then what I would want to do in the short term is system.out that. But this one's a little bit away yet. I have to start with these. So let's start with the binary chopifier. So I'm just going to do Alt Enter to create that class, and I'm going to create the class in the source Java directory, because this is real code. This isn't test code anymore, this is real code. Woohoo! Okay, so next up, we need the binary chop results. So I'm going to create a binary chop results first. Make sure that's in source Java. Then let's add the chop method. And the reason I did the binary chop results first is that it means that IntelliJ knows that the chop method has to return the binary chop results. So this has got the start value and the end value. And what this is basically doing is the code in here. So I'm just going to take this, stick it in here. Now I don't need that. So the diff is the end value minus the start value, while diff is greater than 0. Diff. Then what I'm going to do is I'm going to build a list of chop points. So let's create this, create as a local variable, and it is a list of integer. But I don't want it in the loop, I want it outside the loop. And I'll instantiate that as a array list. Now, rather than system outing it here, what I want to do is create the binary chop results. And I will pass in the start value, because we're going to report on all this afterwards. So I need the start value, the end value, and the chop points. Now this doesn't exist yet, so let's create this. Whoa. Okay, this dot start equals start value. So this is just some boilerplate stuff to get the fields in place. Then IntelliJ can add these fields for me. Now I know that there are various libraries I could use to create boilerplate and thing, create accessors, but I still like to do this stuff by hand. I don't like to have a reliance on external libraries for simple things like this. So all the other methods for accessing it, I'm going to create as I use them. So this binary chopper should be okay now. If I had left in the brackets, there we go. So now we're back to the test. So let's start driving out some of the methods that we need. So I'm going to assert, and say binary chop. Let's bring in the assertions from JUnit. I'll say get start, and I'll assert that that is 1024. That will force me to create the get start method. Now this isn't proper TDD because I'm not writing test code that fails and then putting it in, because most of this stuff is already there. I mean, if I run this test now, it will pass. I haven't seen it fail, so I don't know that this code has made it correct. So the way that I'll get around that is by adding more tests later on to demonstrate to myself that it works. If I use TDD, I don't necessarily have to do that because I'm demonstrating that it works because it was broken and then fixed. So this isn't quite a TDD process. Let's do an assert equals on the get end. And that should be 20. My typing today. 2048. We'll add that as a getter, return this dot end value. Now the reason it didn't autocomplete in there is that get end is different from start value and end value, otherwise it would be able to probably find that for me. So we've got a start and end. So now what I want to do is assert on the chop points. So I'm just going to start an assertion on the number of chop points first. Count chop points. And there should be 11 of those, because what we're doing is calculating this, and there's 11 of them in that list. And this is easy. I'm just going to do this on the basis of the size of the list. So this should be all good so far. Let's have a look. Okay. So now I want to make sure that the values have been calculated correctly. So I'm going to do this the long-winded way. So I'm actually going to just copy this to start with, and we'll amend it. It's binary chop dot get chop point, and I'm going to say the first chop point. So the array list is 0 indexed. I'm going to start at 1 because that makes sense for my reporting here. And the first one should be 1536 because we've got the start as a separate, but the chop point is 1536. So I'll call this chop point index. Now, so this is going to be a little bit fiddly simply because we want the chop points and we want to get the chop points index, but -1 because it starts at 0, but we're going to index it at 1. Let's check that this works. Okay, so now I'm basically just going to feed in these values here into my test. It's not going to be a very elegant test, but it's going to get the job done. And we'll make some more elegant tests later on. So if I run that, that all worked. And the other thing that we're going to have in the report is we called it inc here, but we're going to call it diff. So I want the get chop point diff for position 1, which is 512. So let's code that. And that's chop point index again. Now we don't have this stored, but I'm just going to calculate it. So I can say return end value, or this.end value. I just make this dot chop points. Don't really need to do that, but I'm going to do it anyway, just because. This.end value minus, and we'll use the get chop point for the same chop point index. So we're going to calculate the diff each time because we already have the value. Essentially, we're redoing the calculation that's in here, but I'm okay with it. Let's see if that works. Okay, so now I'm just going to add in all the chop points, diffs. So bear with me while I do this. And there we go, that matches up with what is in the list here. So let's run this test. There we go. I have a different binary chopper. Okay, so let's quickly create a new version of our test utility that uses the binary chop code that we've just done. Calculate binary chop for start and end using library. So I've got a start and an end. I don't need the diff. Create a binary chopper, put in the start, put in the end, and then I'm going to just iterate over this for int x equals 0, x equals 1 because we start at 1, x is less than or equal to the binary chop dot get the count of chop points, x plus plus. Let's take this output that we had, and I'll say the binary chop results dot get chop point at x, and then binary chop dot get chop point diff at x. And the reason I'm doing this is just to keep my tooling up to date. So let me run this. There we go. Let me change this back to 1024, 2048. There we go. So I've still got my old tool, so I don't need this anymore. And I should really just delete this. But we're working through code at the moment. So the next step is going to be, I think what I want is to be able to create a binary chopper, but only with the last value. So let's do that. So I'm going to do something bad here. I'm just going to copy and paste this test for the moment, because what I want is pretty much the same as that. And what I want to do is chop with just the end value. So I'll say binary chop end value only. Let's create this. That's the end value. So really what I want to do is return chop where the start value is the end value divided by 2 end value. There we go. If I run this, it should just work. And what I'm going to do is, because I'm pretty sure this is going to work, I'm going to leave in the check for the start value because that's calculated. I'll leave in some guard conditions for the start and end on the diff. This way I don't have to maintain too much. There we go. That will do. That's good enough. So now I've got a binary chopper where I can specify both points and one where I can specify just the end. So I could, in theory, move this to be just the end now. So let's create a more elegant test. Take the start part, And let's create a test for 128. So that would be 64 to 128. 64, 128. Let's get this right. And I'm just going to use the end version here. So what I have to do now is work out what are the expected values. So I'm going to put these in an array. This will make it just a little bit more elegant. We want 128 minus 64, which is 64. Wow. Divide that by 2 gives me 32. So that means my first value in here is going to be 96. 64 plus 32, or 128 minus 32. And then it's 16, so that's going to be 112. Then 8, so 120, then 4, 124, then 2, 126, then 1, 127, then 0, 128. So let's also add in the diff values. What I should have done is just calculated the diff values and put them in early. That would have been easier. 32, 16, 8, 4, 2, 1, 0. Space that out. There we go. So now x is less than or equal to binary chop dot count chop points x plus plus. Now let's put in a check here. 1, 2, 3, 4, 5, 6, 7. Make sure that's right first. Then I think I will. Have we still got that? Let's use the system.out, stick that in just for visual safety net. Then let's assert get chop point for x is expected values of x minus 1. Then let's assert on the diff. Expected diff values. Okay, let's see if that works. Okay, and because we're paranoid, I'll add another one. I'll add one for 57. So let me just speed this up for a second. So there we go, this is the check for 57. I've worked the values out, 43, 50, 54, 56, 57. We've got 5 of them. Let's run this, see if it works. Okay. So now I have a little bit more certainty that the code is going to work. I've got some tests around it. So the next thing I'm going to do then is create a test to drive out the binary chop reporter. Now, what will we have here? So we're going to have this essentially, and then binary chop reporter, which doesn't exist, equals new binary chop. Why am I trying to code complete? Binary chop reporter for the binary chop results. Let's create that. Let's pass that in the constructor. Let's make that field. So then I'll want the reporter to report a string. And now I will want, so let's just have that return a string. Great. So then I will want to split this. Essentially what I'm going to do now is I'm going to write a test that checks that each line in the report is what I want it to be. And I want the report delineated with the system line separator. That would just make it a little bit more cross-platform. Now, let's start. So I want the first line, because we're using 57, to say start 28. And that would be lines 0. So now I can TDD this out because we haven't got any code behind this. So if I run this, it should fail. Great. So now I can add the code to make this work. So in the get string report, I'm going to have a string builder, and then append. I will append string.format. Oops. Start %d, and then we want the system line ending. So rather than doing \n, I'll do %n. I want that %d to be the binary chop dot get start. And what mistake have I made? Yep. And then let's return that. So let's see how the test is doing now. Okay. That's what I will also do just for completeness. Just so I can just see it as I'm building this up. So now the next line. Now what I'm trying to do here is make it relatively close to my original plan, but I'm going to change the formatting just a little bit. So we're going to say end : 57, because that is the last value, and I want to compare that to lines 1. Isn't live coding fun? So this should fail again. So let's go into, close this down. Let's go into get string report to fix it. So I want the end 57. And get end. Let's run that. Control Shift F10. Okay, we're on a roll here. Now, I'm going to add a blank line. And let's add in the title. And let's add in a nice heading there. There we go. Control Shift F10, failed test. Why am I using string.format when there's no variables? Because I want the line ending. And what did I miss out? I missed out the blank line. And then we want the underscores. Okay, back to the test. Control Shift F10. And we failed because I made a mistake in the test. Control Shift F10. Okay, so now we want the rest of the values. So let's specify these. So I want 1. And 1 is 43. And in brackets, 14. So let's see that fail. Excellent. So I could make that test pass just by putting in the hard-coded line, but I'm going to do this properly. So I'm going to put in for x equals 1. X is less than or equal to binary chop dot count chop points x plus plus. Then let's add it to the report. Right, so we want %d, which is the index, colon %d, which is the value, then in brackets %d, which is the diff, and then a system line break. So index, get chop point for x, get chop point diff for x, and we're good. We run this. Okay, so now everything else is pretty much just a case of building this up. Remember, this isn't great TDD kids, so use this as an example, but try and do better, because I'm taking this in big chunks. But it's fairly simple, so I'm probably overconfident, or possibly overconfident. Right. Let's see if that passes. There we go. I'm just going to add one check in here. This is temporary. I expect this to fail, just to make sure we haven't got any extra new lines coming back. Lines 10. And let me just assert on the size of that array. Assert equals let me move that up top. Control Shift F10. Okay. Now that we've got the binary chop reporter, let's add that into our tool. So I'm going to just have the end. I don't need this anymore, because what I'm going to do is use my reporter, system.out.println binary chop reporter for the binary chopper chop end value dot get string report. It's not called end value, it's called end. Let's get rid of this. In fact, I don't need to instantiate that in a variable, so let's have a new binary chopper there. There we go, that seems fairly simple. Let me run that tool. Alright, so now I have a much cleaner report, and it's all TDD tested, and we're good to check that in. Let me just rename this to binary chop tool. So what we've done is we've taken our basic tool, which was a complete prototype, we've refactored it into libraries. It now has tests around it, and we've retained the tool, but the tool is a lot easier to maintain because it's using the libraries. Just going to do a quick check here for the coverage, see how we did. Okay, so as far as the metrics go, we did fairly well. I might want to review that just to check that I'm satisfied with it, but we've built it up over time, and we're ready now to go to the next stage to try and get this being used by the GUI. So after reviewing the code, let's just do one thing. Let's get rid of the code we don't need anymore. So all these extra tests that we use just to calculate the prototypes, let's get rid of those. And let's fix all of these asserts. Because remember, if I do a Control P here, it's expected followed by actual. So I'm just going to fix all of that. Okay, that is much better. Now I can check the code in.